All right, we're going to take a look at 9.3 here. We're going to split this up into 2 days. So today will be 9.3a. As we get started, we have three different terms right here. The unit circle, a quadrantial angle, and the reference angle. For today, what we're going to look at primarily, we're going to skip the unit circle. We'll get to that tomorrow. Let's take a look at that first term that I have a definition for. The quadrantial angle is pretty much the first quadrant, okay? And the first quadrant happens to be between the angles of 0 and 90 degrees. Right? If we were to draw ourselves our coordinate plane, this right here is the first quadrant, right? This is 0, and we have 90 degrees right there. So that is our quadrantial angle. Uh, the reference angle, we'll come back to that as we take a look. There's a section in our notes that deals primarily with that. So we could talk about that when we get there. Right. Let's go ahead and scroll down. And right here, we have general definitions of trigonometric functions. Now, remember, we have our mnemonic device to help us remember like the sides that go with sine, cosine, and tangent. We had SOHCAHTOA. So if you look right here, all of these sine theta is equal to y over r, cosine theta x over r, tangent theta is equal to y over x. Well, those all actually, first, let's make sure we got to memorize all of these. You memorize these three, that should help you memorize, remember, the inverses of each. The inverse of sine is cosecant, inverse of cosine is secant, inverse of tangent is cotangent. So if you remember the inverses, if you look at sine, it's y over r. Cosine theta happens to be r over y. And then cosine theta is x over r, or cosecant theta is r over x. And you can see that there are several restrictions here when it comes to tangent, cosecant, secant, and cotangent, where the denominator cannot equal 0, and we should know why, because it ends up being undefined. So where does y over r, x over r, all this stuff come from? Well, if we take a look at our quadrant right here, and we have a circle. Now, this is not the unit circle quite yet, but how they get all of this is, first off, if we look at this point right here, they just label it x comma y, because the distance from the origin going this direction would be x, right? That direction is x. Going up right here, that happens to be your y. And we form a right triangle, and from the origin to that point happens to be what we would say is the radius, because we are dealing with a circle right here. Okay, so that ends up being y. This happens to be r, and then we have x and y. Now, I don't care so much about positive and negative, okay? Because there's later on in the lesson, I'll teach you why certain quadrants happen to where certain answers are positive, certain trig functions are negative, okay? So we'll get to that. But if you take a look and we say, all right, we're like taking a look at this angle right here, and we have sine theta. Now, if this is theta, then you can see, remember, sine is opposite over hypotenuse. Well, opposite of this angle is y, the hypotenuse is r, and that's why right here we have sine theta is equal to y over r. And then the same thing goes for cosine theta. Remember, cosine, SOHCAHTOA, adjacent over hypotenuse. So we have the adjacent side right here is x, the hypotenuse is r, so then it becomes x over r. And then for tangent, it is y over x. opposite over adjacent are the two sides for a tangent. So opposite y, adjacent is x. All right. So to help you memorize the cosecant, secant, and cotangent, well, if you find sine, cosine, and tangent, you take the inverse of those, and then that'll get you your cosecant, secant, and cotangent respectively. Okay. And as it says right here, these functions are sometimes called circular functions down at the bottom. All right, we can go ahead and let's highlight that. And they're circular functions. Obviously, hopefully you can tell because we're dealing with a circle right here. As we go ahead and scroll down, like I said, we will skip the unit circle. We will come back to that tomorrow or next time in 9.3b. And let's go to this reference angle relationships. All right, so it says let theta be an angle in standard position. And then the reference angle for theta is the acute angle theta prime formed by the terminal side of theta and the x-axis. Okay. Now, when we talked about the quadrantial angle, remember that's everything between 0 and 90. So whatever happens to be in that first quadrant, that is your actual angle. That will be the reference angle there. Okay, so if I said what we're trying to get at is this. If we have in the first quadrant, let's go ahead and say that's 60 degrees, then 60 degrees will be the reference angle. No ifs, ands, or buts. Okay, that's simple. Now, the thing right here is when we move on to let's look at quadrant 2. Inside quadrant 2 right here, let's go ahead and say that this happens to be, we'll say that our angle in standard position, let's go ahead and put 120 degrees. Okay, so let's say from here, from our initial side to our terminal side, let's say that's 120. Okay, so what they're saying is that our reference angle is not 120. If I look at, start right here from the terminal side, so there's our terminal side, and I look closest to the x-axis, then this amount right here, knowing that this is 180, right? This is half of the circle is 180 degrees. This amount, which is our reference angle, will end up being the remainder. Or you take 180 minus 20, and that's going to be 60 degrees. So that's telling us that this angle is 60. Okay? And so that is the key right here in determining the reference angle. You take whatever angle that they give you as the reference angle, or sorry, as the standard, the angle in theta, the angle in standard position. You figure out where in the quadrant this happens to be, and then from there, you're going to come up, you have to figure out your reference angle by basing it off the terminal side. So if we go to quadrant 3, let's say that the angle given right here let's just go ahead and put that one as, let's say 200 degrees. Okay, so from here to here is 200, then my reference angle is going to be from the terminal side right here to the x-axis. And that right there will end up being 200 minus 180, which is 20 degrees. And that is our reference angle. If we go take a look right here on quadrant number 4, we have from here to here, we'll start with our initial side. We'll go all the way around. Remember, that's 180. This is 270. And let's just go ahead and say that that happens to be, let's say this is 300 degrees. So that tells us that the reference angle will be from our terminal side to the x-axis. And remember, this is 360. So that makes our reference angle 60 degrees. All right. And now they do have little shortcuts and things that you could use to help you determine uh, the different angles, whether it's in degrees or in radians as well. Okay, so those are the four, the different methods for you to figure out those right there. As we go ahead, let's scroll down. And so if you look at this table right here on the right hand side, it looks like there's a whole lot. Okay, it says, remember earlier on I said we're not going to worry about the different side lengths and whether it's positive or negative. You could do it there at that point in time. However, if you look at this table, what they're showing you is that in each quadrant, particular trig functions are going to be positive and certain trig functions are going to be negative. Well, the easiest way for you guys to remember this, we always have our mnemonic devices right here in math, is this. We'll start right here. We'll put it in an A. We'll put the S in quadrant 2, T in quadrant 3, and C in quadrant 4. And your mnemonic device for this is all students take calculus. Yeah, once again, we're not always the math people are never always the brightest or the funniest, but hey, all students take calculus is something that has been uh, preached year in and year out, just like SOHCAHTOA, right? Stupid things we seem to memorize. And here's another one, right? So what they're saying is in quadrant 1, whatever your trig function happens to be will always be positive. In quadrant 2, sine and the inverse cosecant is going to be positive and everything else will be negative. So cosine, secant, tangent, cotangent, those will all get you negative answers. In quadrant 3, tangent and cotangent will be positive, and then the rest will be negative. And in quadrant 4, cosine and secant are positive, and the rest happen to be negative. So if all students take calculus, that is what you're going to be using in order to help you figure out what signs and what is going to be positive in each quadrant. Let's go ahead and move down right here and take a look at problem number 1. So it says evaluate the 6 trig functions of theta. All right, so remember what we are trying to figure out now is right here. We have sine, cosine theta, tangent theta. So for sine, we have, now if we take a look at our triangle, we got to figure out how long the different sides are. X is 2, so we know that this length is 2 right here. We have 6 right there, and I have myself a right triangle, so I could figure out the hypotenuse by using our nice little Pythagorean theorem. Okay, so we have, let's put right here 2 squared plus 6 squared is equal to c squared. And we got c is equal to rad 40. We can go ahead and let's make sure it's in the simplest radical form. And we have ourselves right here 2 rad 10 for side C, okay, our hypotenuse. All right, so then we should be able to go ahead and figure out our different ratios right here. And once again, you could either remember before, above, we talked about the different ratios, the definitions of trig functions. Sine is equal to y over r, cosine is equal to x over r, tangent is equal to y over x. And you could use that to help you answer these problems. Or once again, we could use technically our acronym of SOHCAHTOA to help us get our solutions. So let's go ahead and do that right here. So for sine, we have ourselves opposite over hypotenuse. Remember, this is theta right here. So opposite is 6. Hypotenuse is 2 rad 10. Don't forget, we do not want our answer we need it in simplest radical form. So, and no radicals in our denominator. So let's go ahead, I'll simplify this to 3 over rad 10. And then remember, in order for us to get rid of our radical in the denominator, we're going to rationalize by multiplying top and bottom by rad 10. So what that's going to give us is 3 rad 10 over 10. There's our sign. For cosine theta, adjacent over hypotenuse, so we have ourselves 2 over 2 rad 10. If we simplify that, that gets us 1 over rad 10. We'll rationalize this again by multiplying top and bottom by rad 10. And that right there will get us rad 10 over 10 as our solution. Okay. And then finally, the tangent one is the easy one because it's opposite over adjacent right here. And it happens to work out nicely where they're both nice whole numbers. And then we have ourselves 6 over 2, opposite over adjacent. And we get our answer of 3. All right. So let's go now. The inverse of sine is cosecant. So cosecant theta, remember, is the inverse. And we can simply take, if we take a look at our answer right here, our initial answer, we could take the inverse of that, and you get 2 rad 10 over 6, which simplifies down. Let's go ahead. Or we could take this answer and then change that, take the reciprocal, and our solution is rad 10 over 3. The inverse of cosine is secant. And our answer right there will just simply be rad 10. Take the inverse of 1 over rad 10. And then for cotangent, we'll go ahead and take the inverse of 3, and that's going to be 1/3. All right, and those are all 6 of your trig functions right here, all in one. All right. We are skipping the unit circle 3 and 4. We'll come back to that tomorrow or next time. And let's take a look at number 5 next. So number 5 right here, There, so let's sketch the angle and find its reference angle. So negative 310. Now remember, if we're going negative, we actually go clockwise from our terminal side. Or sorry, our initial side. So our initial side is right here, always. And let's go clockwise this time. So we're going to go from here to here. That's 90. We have 180. The next quadrant adds up to negative 270. And then we got to figure out, well, where the heck is 310? So if that's 270, 310 will end up being another 40 degrees or so. So let's put it right there. It's not going to be much. And so this is negative 310 degrees. So looking at 310, and remember this over here is the same thing as 0 degrees or 360. They're coterminal angles. So the amount to go from negative 360, or sorry, negative 310 to negative 360 will be, well, you go ahead, you can subtract the 2 and then get your answer. But this happens to be a total of, right here, 50 degrees. All right. And that right there will end up being your reference angle, 50. We take a look at number 6. Now, to find our reference angle right here, this is in radians. Well, that doesn't do us much good when it's in radians and you don't know where that is exactly. So, well, don't mind that train. Stops by every once in a while. We're going to take this from radians to degrees. And let's go ahead. Remember, in order to change this from radians to degrees, we're going to multiply this by 180 over pi. And so you could take your calculator, you could figure out what exactly or where exactly that happens to be. Don't forget to use your parentheses. But this happens to actually equal 486. Now 486 doesn't do us very much good because it's more than 360, right? But we can figure out our coterminal angle. And let's take 486 and let's subtract 360 from that, okay, to figure out our coterminal angle. That happens to end up equaling, right here, 126 degrees. So we start from our initial side, 0 degrees right here. We'll go end up right there. That's only 90. We get 180 if we go all the way down to this side, so that's a little too much. And so 126 will end up being this much. Remember, we need to figure out the reference angle. How close is it from that terminal side to the x-axis? And this is our reference angle. We can go ahead and take 180 minus 126. And from there, you'll end up with your answer of 54 degrees. And this right here is your reference angle. Let's see if we need to do the last problems right there. All right, let's take a look and let's see how we could evaluate. Take a look at number 7 and evaluate that without using a calculator. In order to do that, we need to start off with let's go ahead and I'll make myself an axis right here. And it says, let's evaluate the function of cosecant of 150 degrees. All right, so let's figure out where is 150. We start from our initial side. We go from here to here. This is 90. And we go a little bit more. And we'll end up with 150 being right around here. So that's 150 degrees. Well, what I really need to figure out is our reference angle. And that happens to be from 150 down to our x-axis. That's 30 degrees. And guess what we have right here that'll allow us to figure out our sides is a 30, 60, 90 right triangle. So remember, earlier on in the chapter, talked about 30, 60, 90. And remember, side opposite of 30 is x, opposite of 60, x rad 3, and then opposite of 90 is 2x. So if we make things simple and we'll plug in, let's say, we'll say x is 1, then that'll make our sides a lot easier because opposite of 30 will be 1, opposite of the 60-degree side will be x rad 3, or sorry, 1 times rad 3, or just rad 3. And then opposite of 90 will end up being 2x, or 2 times 1, which happens to be 2. So let's go ahead. Let's figure out, well, remember, the inverse of cosecant is sine. So if I figure out right here using the reference angle, okay, let's use the reference angle first. I'll start off with sine theta, or we actually know what the reference angle is, so we can say sine 30 and then we can go ahead and say sine is opposite over hypotenuse. That's 1 over 2. So I'm using sine theta because I know that that is the inverse of cosecant. And then so I can go ahead and say that cosecant theta is equal to the inverse of that, which is 2. And that right there is your answer. And that's how you do it without a calculator. All right, just that simple. You can come back and we'll take a look at 9.3 and we'll do a few more problems evaluating different functions as well, along with the unit circle.